Hello everyone, today we walk you through the science behind our 4-pillar system, an all-round solution tackling every pathway marine plastic takes into Hong Kong water.
Starting with surface runoff, the first mechanism uses electrochemical mineralizations with thorium-doped diamond electrodes. When voltage is applied, the electrode's high oxygen evolution potential splits water rather than oxidizing chloride ions, producing no toxic chlorine gas. Hydroxyl radicals generated at the electrode surface pulls hydrogen from the plastic polymer backbone, leaving unpaired electrons. These carbon-centered radicals react with dissolved oxygen to form peroxyl radicals, triggering a cascade that breaks carbon-carbon bonds and shortens the chain. This cycle repeats until every carbon becomes carbon dioxide and every hydrogen becomes water.
Moving to soil seepage. The second mechanism targets plastic migrating through groundwater using a symbiotic system of native plant roots and fungal hyphae. Fungal hyphae, just 20 to 50 nanometers wide, form a subsurface network that physically traps microplastic particles. Native fungi secrete enzymes including lactase, zinc peroxidase, and manganese peroxidase. Lactase removes electrons from phenolic structures, generating reactive intermediates that break chemical bonds. Lignin and manganese peroxidases use hydrogen peroxide to produce hydroxyl radicals that attack the polymer backbone. These reactions cut long chains into short organic acids and sugars, which plant roots absorb as nutrients. In return, plants supply glucose to the fungi, creating a self-sustaining cycle.
For airborne microplastic, the third mechanism uses sunlight for capture and degradation. Native plant leaves with fine hairs trap particles from the air. A titanium dioxide photocatalyst combined with carbon quantum dots enable up conversion. Carbon quantum dots absorb 2 low-energy photons and emit 1 high-energy photon, exciting titanium dioxide to generate an electron-hole pair. The electron form a superoxide anion with oxygen, while the hole form a hydroxyl radical with water vapor. Both reactive species break polymer chain until complete mineralization to carbon dioxide and water occurs. The catalyst works under visible light, so degradation happens even on cloudy days.
Finally, for plastic accumulating in neutral waters, the fourth mechanism couples enzymes with photocatalysis. First, salt-tolerant chutinases and petases, stabilized by salt bridges, hydrolyze ester bonds in plastics like polyethylene terephthalate, cutting long chains into small molecules, such as terephthalic acid and ethylene glycol, increasing surface area for the next stage. Second, a single atom iron-nitrogen-carbon photocatalyst absorbs light across the ultraviolet to near-infrared spectrum, generating electron hole pairs that produce superoxide anions and hydroxide radicals. These reactive oxygen species rapidly oxidize the small molecules. The final products are carbon dioxide and water, released without physical collection.
Together, these 4 mechanisms form a truly comprehensive system. Complete mineralization, no microplastics, no toxic byproducts. Thank you.